Hey guys, so we're going to follow along with your packet on the summer review notes day 3 to do some examples. So we're going to do numbers 1 through 4 together, and then you're going to try 5 and 6 on your own on the next slide. So on the very first example, we have a greatest common factor of 3. So every single term we can factor out a 3 or divide each factor by 3. So we're going to take the 3 out at the beginning. And basically what we're doing now is dividing each term by that 3 that we just took out. So 3x squared divided by 3 gives me x squared. 24x divided by 3 gives me positive 8x. And 45 divided by 3 gives me 15. So if you're unsure about how factoring out a GCF works, that's basically how it works. Whatever you take out is what you're dividing each term by. So now we want to ask ourselves, since we've got a trinomial in here, we want to ask ourselves what two numbers multiply to equal 15 and add to equal 8. And the reason that we're doing that is because we have an invisible 1 right here in front of the x squared, and 1 times 15 is 15. So we need two numbers that multiply to equal 15 and add to equal 8. Okay, those two numbers would be positive 5 and positive 3. So we factor into x plus 5, x plus 3. And now all we have to do is set each factor equal to 0. So a lot of people get confused and they think, oh, that means I need to set 3 equal to 0. No, you don't. 3 doesn't equal 0. There's no reason to set 3 equal to 0. It's never going to equal 0. The only thing you need to do is set x plus 5 equal to 0 and x plus 3 equal to 0. So if x plus 5 equals 0, then x equals negative 5. And if x plus 3 equals 0, then x equals negative 3. So those are your two answers, which means on your parabola, you would have a parabola that crosses the x-axis at negative 3 and negative 5, and it would look like this. That's a little rough sketch of it. So on number 2, the difference between number 1 and number 2 is a couple things. First of all, there's nothing in front of c squared. Like this one had a 3 in front of the x squared as its coefficient, but c squared doesn't have anything in front of it. But also, not every term is on the same side. We need to move all of our terms to be on the same side. You could move this c squared over to the right side by subtracting it, but I personally like my first term to be positive. I don't really like the squared term to be negative. So I'm going to subtract 2c and 99 to the other side. So I'll have c squared minus 2c minus 99 equals 0, just like that. So now I'm going to do the same thing that I did in this section over here. I need two numbers that multiply to equal negative 99 and add to equal negative 2. And those numbers are going to be, let's see, negative 11 and positive 9. So this becomes c minus 11 and c plus 9 equals 0. And if you're not sure if you got the correct numbers, what you can do is FOIL it back out and see if it works. So c times c is c squared, c times 9 is 9c, negative 11 times c is negative 11c. So if you added the 9c and the negative 11c, you would have negative 2c. And then you would do negative 11 times 9 to get negative 99. So it works out that you end up with two factors that if you FOILed them would give you what you started with. So now we just need to set c minus 11 equal to 0 and c plus 9 equal to 0. So c equals 11 and c equals negative 9. So on this graph, you'd actually have a pretty wide parabola because you have a 0 over here at positive 11 and 1 over here at negative 9. So it's going to be a pretty wide looking parabola, just like that. Okay, on number 3, we only have two terms, and we still want to get both of them on the same side. I want my squared term to be positive. I just like it that way. If it doesn't bother you, you don't have to worry about doing that. Which means I'm going to move 9z. So I'm going to have 0 equals 10z squared minus 9z. And I like to put little dashes through my z's so they don't look like 2's. Now you might notice that this looks a little different. You don't have a last number. You don't have a C value or a constant. Like this one had 45 and this one had 99 before it became negative 99. This one is just like a 0. There, you could write plus 0 or minus 0. So what that means we can do is we've got a like term or a greatest common factor here of z. So I can take a z out of both 10z squared and 9z. So I'll have 0 equals z times, remember if you factor something out, that basically means you're dividing by it. So 10z squared divided by z gives me 10z, and then negative 9z divided by z gives me negative 9. So you're just taking the z away from both 10z squared and negative 9z. So now my factors are z and 10z minus 9. So you do need to set z equal to 0, right? Z can equal 0. It's not the same thing as we had up here where we had a number out in front of our factors. Z is a variable and it can equal 0. So you do need to set it equal to 0. And then 10z minus 9 equals 0. So 10z equals 9. So z equals 9/10. Okay, so my parabola would pass through 0 and 9/10, which are going to be really close together, like that. Okay, you may wonder why I keep drawing my parabolas facing upward. It's because my my squared terms is positive. So I've got 10z squared, I had 3x squared, I had positive c squared over here. None of those had negative numbers in front of them, so that's why all my parabolas are facing up. Okay, on number 4, I've got 5w squared over here, and I want to move my other terms to be with it. But right now, they're kind of factored out, which is a little bit unusual. So I'm going to take that 5 and distribute it back to the 7w minus 12, so it looks a little bit more normal. So 5w squared equals 35w minus 60. All right, and then I'm going to move these two terms so that they'll be on the other side with 5w squared. So 5w squared minus 35w plus 60 equals 0. All right, now I do have a greatest common factor here of 5. So I'm going to take the 5 out, which means each term gets divided by 5. So I'll have w squared minus 7w plus 12 equals 0. And now I just need to factor this part right here. So I need two numbers that multiply to equal 12 and add to equal negative 7. And that would be negative 3 and negative 4. So I'll have w minus 3 and w minus 4 in addition to that 5 that we had already factored out. Okay, so again, I'm not going to set 5 equal to 0 because 5 does not equal 0. There's no way for 5 to equal 0, so there's no point in me setting 5 equal to 0. But I am going to set w minus 3 and w minus 4 equal to 0. So if w minus 3 equals 0, then w equals 3. And if w minus 4 equals 0, then w equals 4. So this parabola is going to cross at positive 3 and positive 4. All right, try number 5 and number 6 on your own, and the next slide will show work so that you can check your progress.